Most adults get around 4 colds per year, but some people feel they always get cold, while others say they almost never catch a cold. In reality, the human body fights hundreds of viruses and bacterial species every year, but most of these infections are mild or completely unnoticed. Our immune system destroys most of them before they cause any harm. If 100 people are exposed to different viruses, about 20 of them will almost never develop any symptoms. The immune system destroys most viruses before illness starts. Around 25 people will catch almost every virus they encounter and develop clear symptoms, and the remaining 15 fall somewhere in between, sometimes showing symptoms and sometimes not, depending on their immune response and overall health. The key differences between people who rarely get sick and those who get sick often depends on several biological and lifestyle factors. First, and one of the most important, is early exposure and immune memory. The healthy people usually encountered more viral families earlier in life, especially through childhood exposure, pets, and natural environments. Their B and T cells have already memorized many viral fragments. When the same or similar viruses appear again, these memory cells quickly recognize and neutralize them, preventing infection from progressing. In contrast, the always sick group often has a narrow immune history and lower cross-reactivity, so new viruses spread more easily before the immune system reacts. The second important factor is genetics and interferon response. Some people are born with genetically stronger pattern recognition receptors and that detects viruses faster. These receptors trigger a rapid interferon response, activating antiviral proteins that block viral replication within hours. Genetics therefore strongly influence how fast innate immune system raises the alarm. The third factor is airway health and mucosal integrity. The condition of the nasal and bronchial mucosa is crucial. Smoking, air pollution, chronic rhinitis, asthma, chronic bronchitis, and dry air all damage the cilia that swaps viruses out of the airways. Such chronic irritation is far more common in the always sick group. The fourth factor is sleep and stress. Sleep deprivation and chronic stress weakens antiviral immunity. Studies show that people who sleep less than 6 hours per night have around 50% weaker protection against viral infections. Also, cortisol, the stress hormone, suppress immune cell activity. And fifth is microbiome diversity in our gut. The microbe plays a major role. The gut is the largest immune organ in the body. About 70% of immune cells are located in the gut-associated lymphatic tissue. Healthy gut bacteria constantly send chemical signals that train immune cells traveling to the lungs and airways. A diverse microbiome supports faster and more balanced immune responses. And sixth factor is hormonal balance. Hormones strongly influence immunity. Both overactive and underactive thyroid function and low estrogen or testosterone levels reduce immune efficiency. And seventh factor is genetic variations in immune genes. Some people have protective molecular patterns on their immune cells that make antigen presentation and virus recognition more effective. These differences also affect how strongly cytokines, immune signaling molecules, are released, influencing the intensity and coordination of the overall immune response. So, we already know what is the problem. Now let's say how to improve our immune system. First is annual vaccination against influenza. It reduces risk of severe flu with high fever and fatigue. Flu usually strikes once a year, and vaccination lowers severity and complications. Other important vaccines are pneumococcal vaccines, pertussis, HPV, also reduce serious respiratory and mucosal infections, indirectly preventing viral bacterial synergy, which often worsens illness. The second factor is early and natural microbial exposure during childhood or adulthood, interacting with richer microbial environments, gardening, contact with soil, or spending time in rural or green spaces improves immune adaptation. These exposures increase microbial diversity and train the innate immune system, leading to fewer allergies and fewer respiratory infections later in life. Third factor is nutrition and microbiome support. Eating high fiber foods support gut health and immunity. Short chain fatty acids like butyrate and acetate strengthen mucosal immunoglobulin A, IgA, and T cell memory. The good sources are oats and barley, beans, lentils, bananas, apples, pears, carrots, chia seed, and flaxseed. Fermented foods are also good, such as yogurt, kimchi, and kefir. They also improve gut microbiome. Among probiotics, strains like Lactobacillus rhamnosus and Bifidobacterium lactis are the most studied and effective. Regular intake can reduce upper respiratory tract infections around 30% according to meta-analysis. And vitamin D supplementation, vitamin D 800 to 2000 international units daily significantly reduces respiratory infections, especially in those who are deficient, and nearly half of global population has low vitamin D level, so regular supplementation is recommended, particularly in winter. And now let's say how to support sleep and interferon activity. Although genetics influence interferon responses, sleep can naturally boost it. Sleeping 7 to 8 hours per night helps maintain optimal interferon production. Even 2 hour sleep deficit can lower interferon levels up to 40%. Some micronutrients supporting interferon and antiviral defenses. For example, zinc up to 40 milligrams per day, gluconate or citrate forms, supports immune cell activity. Selenium 100 to 200 micrograms per day acts as an antioxidant and improves interferon efficiency. And vitamin C 500 to 1000 milligram regenerates interferon producing cells and provide antioxidant protection. And acetylcysteine or NEC 600 milligrams twice daily. It replenishes glutathione, boosts interferon response, and acts as a mucolytic. In older adults, NEC supplementation can reduce flu-like episodes up to 50%. Now let's say what we can do for bronchial responsiveness. Several practical measures can help protect airways and reduce viral irritation triggers. First is maintain humidity, indoor humidity, 40 to 60%, use humidifier. If humidity drops below 30, because viral transmission triples when overlight dry air. Balanced humidity keeps air mucosa moist and supports mucociliary clearance, the natural process that removes viruses and particles. Stay well hydrated. Drink around 2.5 liters of water per day to keep mucosal viscosity optimal. Proper hydration helps mucus move smoothly through the airways, preventing congestion and irritation. Practice nasal hygiene, nasal irrigation with isotonic saline sprays or rinses once or twice daily can reduce viral load and allergen accumulation by around 30%. This helps clear pollutants and support local immune defense, and reduce pollutants and airborne particles using HEPA filters at home, which can remove up to 90% of airborne viral and pollutant particles. This is especially beneficial for people living in urban areas or during smoke seasons. And support to epithelial and anti-inflammatory repair. It's possible with vitamin A, 2,500 international unit per day, supports epithelial regeneration in nasal and bronchial mucosa. Omega-3 fatty acids, 1 to 2 grams per day, help reduce airway inflammation and may improve overall lung function. Magnesium glycinate or citrate, 400 milligrams daily, helps to reduce bronchial hypersensitivity by relaxing smooth muscles and lowering histamine release. You can't directly modify your genetics, but there are several indirect ways to influence genetic expression and improve immune reactivity. Vaccines for them are best. They create not only just antibody memory, but they also reprogram innate immune cells such as monocytes, macrophages, and natural killers to respond faster and stronger during future infections, even to unrelated viruses. This effect is called trained immunity, and it can partially bypass genetically slower interferon or pattern recognition receptor responses. For example, BCG vaccine, tuberculosis vaccine, was shown to reduce respiratory infections by around 30 to 40% in adults and elderly. Similarly to influenza and COVID-19 vaccines, creates cross-priming of interferon pathways, improving how quickly the immune system reacts to different viral families, and nutrients and epigenetic regulation. Polyphenols like EGCG from green tea, curcumin, and resveratrol can modify histones, producing anti-inflammatory gene patterns and reducing chronic immune overreaction. Exercise and cold exposure also effective. Regular moderate exercise increase NK cell function and interferon activity by around 25%. According to immune physiology studies, it also enhances immune surveillance and antiviral readiness. Cold exposure and contrast showers, alternating hot and cold water, have been shown in small but consistent studies to upregulate interferon beta genes and strengthening early antiviral defenses. This effect appears modest but reproducible in different populations.